So without any further ado, I wanted to show this picture of my school. This is the Polytechnic of Milan. It was founded in 1863. And as you can see, the building is pretty old, and it's a very traditional university. And I want to use this as an excuse to tell you why am I degreed in architecture and not in product design, and why Italian designers are so in love with furniture and we are so weak in other fields. So, of course, this university had very ancient root, and the only faculty that was there, if you wanted to be a product designer at the time, was exactly architecture. There was no faculty of product design. We were actually the last country in Europe to set up a faculty of product design, which happened, if I'm not wrong, at the end of the 90s. So now we have this university, which is like first in Italy, first in Europe, fifth in the world, but actually first non-private university. But at that time, there was no such thing. And this made exactly sense at that time, because this is what happened in my days. This is Falling Water by Frank Lloyd Wright. The architect was designing a villa, a residence, and he was taking care as well of the interiors. And in the interiors, the product design that was appearing was designed by the architect himself. So chairs, tables, beds, sofas, you name it, were designed by the same person that was designing the villa itself, so the residence itself. So if you want, at that time, this was the scheme that was going on. There was a client that was calling or falling in love with an architect slash designer, so that the same person was incarnating the two figures, which was very central in the process. He was calling and ruling all the suppliers, from the construction company to the wood or metal company that was making the furniture, and he was calling the engineer when the things were going a little bit tougher, or when he needed some calculations for the construction, the structural part of the building. And at that time, the architect designer was taking care about the interior and the exterior as well of the space. Nowadays, in just 20 years, I believe there was a kind of revolution in our field, in the industrial design field. So the field now is much more diversified. It's much more divided in many other subfields. Think about all the product designers or industrial designers that are working in the field of transportation, car, trains, bicycles, motorcycles, you name it. Designers like me that are involved pretty much in devices. Designers that are specialized in appliances, washing machine, dishwashers, fridges, ovens, everything that it's a white good that goes in the kitchen. Naturally, furniture. In Italy, is still a big thing. We still have the company making furniture, and they still sell all over the world. But then there's kitchenware as well, like tableware, kettles, everything that the soft part that goes in the kitchen. And of course, the fixtures and fittings. So in a few years, we got in touch with companies that built an entire ecosystem of design products. Think about Apple, think about Xiaomi, or think about all the huge ecosystem of Samsung, for example. And they design from smartwatches to audio products, tablets, laptops, computer, even TVs and speakers. And we're pretty comfortable in buying all these different products from just one company. If you take a look at the Google ecosystem or the Apple ecosystem, which are very similar, or the huge one, which is Xiaomi and Samsung, you will find a lots of different products. And in order to develop these different products, of course, the supply chain, the product development chain of a product has been, it's now very complex. And as you can see, the industrial designer is not anymore in the center of the whole of the whole system. So you have a client that, yes, is calling an industrial designer, but he's also calling a marketing company. He's calling a PCB company. PCB means printed circuit board, so it's the electronic that stays inside a product. A PCB suppliers that actually print the electronic. This is all about the interior of the product. Then you have, for the exterior, probably a material supplier, whether the shell is in plastic or in leather or in metal or whatever. There's somebody that makes the mold of the shell, of the object containing the electronic. There's an assembly chain. There's probably a PM or PD, a product manager or product development, that has his feet in all the fields, and it's connecting all these different companies and these different entities all together. We have a distribution channel, which is crucial nowadays. Distribution channels are people called Amazon, Taobao in China. They are crucial to a successful delivery of the product to the market, and then the market gives back the money to the client. So as you can see here, the situation is extremely more complex than what we had before. And if you take a look at the time to market, there was another incredible revolution. There was a push towards the limit of zero. This is a kind of joke. It's a stretch, of course, but think about Stonehenge as the first clock that to measure time that human beings have constructed. It was made in 3000 BCE, and it took 1,400 years, almost 1,500 years, in order to be built. But if you fly back to last century, in the mid last century, probably a chair like the Eames chair took probably 5 years in order to be developed. And in the 60s, where you had all this boom of transportation design and the middle class demanding for transportation, a Vespa could have probably needed 4 years in order to be put on the market. This is the time in which Raymond Loewy in America was already designing for the big car companies for kitchenware in his profession. In the 70s, time in which still the German Dieter Rams was doing his fantastic job for Braun, the typical product of that complexity that could be a TV set probably would have taken 3 years in order to hit the market. And going back to 2015, which is yesterday, it's literally yesterday, a smartphone was taking 2 years in order to go in the market. Well, now our clients are asking products from the brief to the shelf of the supermarket or the Apple store, or sometimes the shelf is also an internet platform like Amazon, Indiegogo, or Kickstarter. They ask it in 2 to 4 months. So as you can see, the push towards speed is absolutely incredible. And as well, things have changed in the lifespan of a product. If you think about the Vasily chair by Marcel Breuer, well, it didn't even stop in the 60s, because actually it's still in production today. But the patent lasted from 1920 to 1960. Now think about a modern product like a laptop. You're very lucky if your product can stay on the shelf of the supermarket for 1.5 3 years. You're very lucky if something like this happens. So to summarize this revolution that is happening, is my strong belief that the expertise, the skills that are required to a modern product designer today are managing and organizational skills in order to manage this speed, this incredible speed that the market has, and on the other side, to be able to have the culture and the vision to see the future 1 year ahead. But in the electronic device market, even 6 months make you a genius, because of course, if you're able to anticipate the moves of the market of 1 year and 6 months, you're very you're very successful. So, Emre, I want to show you this picture because this is the typical product development chain that that a modern product designer is facing nowadays. If you're taking a look at the specific fields of electronic design, So there is a client that sometimes comes from India, from Egypt, from anywhere in the world, that has a company either on the East Coast or the West Coast, in the East Coast in California, in the Silicon Valley, or in the West Coast in the United States. He calls the designer. I always hope it's me, between Cyprus and Italy. Let's say in Europe. I want to add something to this. The people that are involved in this chain, which are basically always the same, because I always find the same companies and I always speak with the same people. They don't even ask you your geography; they ask you your time zone in order not to disturb you at 5 o'clock in the morning. That's the only thing that it's interested in all this process. There's a PCB design company that is usually based in India. Indians are very good at designing electronics. The PCB supplier could be in India, but recently much more in Vietnam. Plastic definitely comes from Malaysia. The assembly chain is in China, and the distribution channel is in Hong Kong, which distributes usually to markets in North America and Europe. And there's a poor PM, a poor product developer guy that follows the whole chain and needs to have a foot in both the worlds, so in the Western world and in the Eastern world, which is the real factory of the world. So this is kind of the environment that I want to describe you in this revolution. This map is actually real. It's related to a product and to a company. The company is called Cool, and from their website, I try to explain it in my own words. Then, Cool provides advanced, high-to-end Internet of Things-based visual artificial intelligence solutions for brand and retailers. What do they do? They have a camera. This camera is mounted in general in supermarkets, sometimes in vertical refrigerators, or sometimes in the shelves. The camera, which actually has two eyes, so it has two lenses, two cameras, take a look at the inventory of products and can understand when a product is missing. So when a certain amount of products are missing from the shelf, then because it's cloud-based, they can send a direct link to the beer company or to the drink company, whatever, to Coca-Cola, in order to have the refill. Naturally, this is today, but the future of this camera is way more interesting. And here we kind of get into a kind of minority report thing. So this camera can tell you, will probably tell you if the door of the fridge has been kept open, or if you just grabbed your beer and took it away. So which kind of cell was that? If it was an instinctive one, or a much more thought one. It can tell you where the product was, so the shelf level. It can tell you at what time the product was sold, and of course, in a futuristic environment, it will help to profile the client, telling you, for example, if the client was a woman or it was a man, or through some biometrics, maybe if he was happy, he was smiling, or he was sad about, or if the product was just a commodity. And here we're talking about the future. So this is the camera, which is absolutely legit. The camera that Cool have, as you can see, is a camera with two eyes, two lenses, and the main problem of this camera was the accuracy. I don't know the numbers, but this camera was like 95. They were going for 98 accuracy. Let me explain what it is. So these cameras are mounted in different situations, in the corridors, in the aisles of supermarkets. And as you know, depending on the chain, whether it's Amazon supermarket, whether it's Unilever or Ocean or whatever, they have different sizes. But it's also mounted on different type of coolers. So you have horizontal coolers, the one where you find the ice cream and the pizzas or whatever. You have the vertical coolers, where you find the yogurt and all the milk-based product. So the main problem is that when the camera is far from the product, it can have a field of view that can get a lot of product. But of course, if it's mounted very close to the product, then the field of view is reduced. You have more resolution, so in a way more accuracy, but you need either more cameras or accessories. And this is how we started with this company, designing accessories, different types of joints and for different mountings, wall mounting, shelf mounting, fridge mounting, vertical, horizontal, depending on the type of fridge, things that were movable. You don't want movable things in supermarket because you don't want the final user, which is the client of the supermarket, to mess up with this product, but you don't even want your people that are doing the inventory to mess up with this product. So we ended up with a different product, which is called Camera Vista. Actually, our nickname for this product is the Star Wars cam, or the Stormtrooper cam, because it looks like one of those Star Wars bad guys, the robots of the Death Star. And this camera still has these two cameras, which are mounted on a system. It's a kind of cone. Now I'm going to open the object. As you can see, there are these two cones, and first of all, there are batteries. There are replaceable batteries inside. So at that time, a person from the company, if the battery was dying, had to go there and change the battery. Now the owner of the supermarket or the chain can do it by itself. But as you can see, these two cones, they have a kind of gear, so they can rotate. So this means that during the assembly process, which in this case happens in China, the workers, according to the type of clients that the company is selling to, can decide whether to put the cameras looking very, very far or very close, or having different angles for different typologies.
Meet the new Camera Vista. Automated image recognition with 95% accuracy. Long battery life. Asset tracking. Out of stock and share of inventory. Cabinet temperature. Planogram compliance and purity to identify unwanted competitor products. Utilization and health. Water and dust resistant. Has preventative maintenance. Tracks consumer engagement and utilization. Peel and stick takes 2 minutes. And much more.
The system that we set up, but it's basically the system that every designer in this field has set up, is related to a few things that we all use. Well, first of all, we make a massive use of a cloud-based CAD called OnShape. So this is not a software that stays on your computer. It's a website where you can actually go subscribe and start designing 3D products inside of the website. It's not a toy. It's not a gimmick. We're talking about the best CAD nowadays in the planet. It has, of course, because it's online. First of all, it's mobile friendly. You can use the same CAD on your phone if you're in a train or in a plane, doing small modification to the product. It doesn't have to be updated. It's always updated. It doesn't even have files because the files are there in cloud. So you don't mess up with the version number 1, version number 2, version number 3. There's no confusion in that. It has a strong data management part. So all the approval part is very quick. Remember that the target here is ship, and be quick. So the data management is crucial. Of course, it has collaboration tools, so all the companies involved, they work in the same system. Let me give you an example. A good friend of mine, Tony Edison, the company that makes the electronics, for example, could possibly change the size of the electronics, so that changes the overall appearance of the design. So you can set limits to them and say, okay, we want the PCB to stay into this limit because otherwise it becomes too bulky or too big or too tall or too thick for some limits that the company would give you. It has strong analytics and reporting, so you have a very clear idea of who's working on what, and you can actually follow their screen. And the part that I love is all the integrations and the partners they have. So there are integrations, for example, for structural calculation. Many of these products, they have to go through some testing in order to be put on the market. Some testing related, for example, to temperature or to shocks or to water resistance. Well, with this integration, the computer can simulate some of this environment. So this is the software in action. This is the open camera. This is the PCB part, as you can see, as I described before, the two gears. And as you can see, this file has been shared with a certain people and certain groups that can make comments inside the file, that can upload the data sheets, images. The client can say, no, I'm not approving this shape, I'm approving the other one. It has a very strong history of construction, so you can also leave the path for a crazy shape and then maybe go back and the history remembers all of this. One of the integrations that we use most, and this is a very it's a very time-saving thing, is called iMaterialize. So this is a company, this is a prototyping company. They're based in Belgium. So what we do is usually we send the file to this company. They have all the pieces. They have all the pieces of the file, and they produce 2 copies of the prototype. One comes to us. 3 copies. Sorry. One comes to us. One goes to the client, and one goes to the PCB designers. So on a random day, we all get a DHL or UPS carrier at our door, ringing the bell and bringing us the exact same product that we can discuss in a video chat. Or imagine that years ago we were doing the prototype. The prototype was going to here, to the United States, from the United States to India. It was a total mess. So this is another very good time-saving tip. And then, like all the startups of Silicon Valley, the startups in China as well, we have our project management platform. There are many. There's Notion, Monday, whatever you name it, Slack as well. It could be used like that. We use Trello. Trello is a board in which you can upload pretty much everything, images, PDFs, data sheets, whatever, files as well, and people can comment inside. So this is called, these softwares are called email killers, meaning that substantially we don't have any email thread going on with the clients, or everything happens here. No WhatsApp messages, no Skype messages, everything happens in here, and it's a very clean platform because you can tell who did what at a certain time, and you can mention people. So see here that they're writing me something, and I said, okay, we're not fine with this one, we have a problem with that one. So it's a very good way to communicate and to keep the things quick and clean. It's very difficult to say, but some of the technologies that we have in our hands today are becoming reality. Well, one is definitely AR VR technologies. I'm experimenting a lot with them. I really believe it's gonna be the future. So the idea of different people in different parts of the planet looking at the same thing, looking at the same engine, the same design piece, and moving them together and understanding where the problem is. Imagine a company that needs to give you a support for a very complex machine, like the engine of a car or the engine of a train, and with these difficulties in flying, they're not able to reach the device itself, but they have to do support online. And naturally, the collaboration part of these spatial horizon workrooms. I know that it's still a toy now, it's still a gimmick, but I think after the pandemic, everybody wanted a little bit of a bigger human value in this Zoom meetings that we're having, and wanted to see at least that you have somebody near you. So this platform are pretty good to design things together. One of the things that I'm mostly interested in VR is all the modeling part, the design part in VR. There are incredible software like Gravity Sketch that actually in which you're actually able to design things in 3D and appreciate the sizes, the proportions, and move the object while you're designing. It's absolutely cool. And one of the biggest technologies that some of my colleagues think of as a threat, I just think is so cool, and it's going to help us so much in the future, is the so-called generative design or topology optimization. So because this software, they have, you can give them some limits. For example, in this kind of joint, you can say, okay, I have 4 fixed points, which are the screws, and I have this cylinder in which a cable is passing, and that cable is applying to the joint a certain force. Well, on the top left, you'll probably see what a designer like me would have done. On the bottom right part, you would see like the artificial intelligence of the computer would do. So as you can see, there's between 60 to 80% less material there. It's lighter. Imagine how it would be useful to send to space, for example, or in the automotive industry, to create pieces that are lighter nowadays. And this is one of the technologies that I'm strongly looking at, because I really believe it's the future of design. It's not going to kill the work of us, Emre, us as product designers, but it's going to help to design better products for sure.